Having discussed algebra and geometry in the previous classes, today we'll study a link between algebra and geometry through chapter 7, which is coordinate geometry. Now, what is coordinate geometry? It was actually invented by René Descartes. He was a French mathematician, and it is also called analytical geometry or Cartesian geometry. And what is it all about? Here we are going to study geometric figures by plotting them in the x and y axis on a coordinate plane. So whenever we are considering two dimensions, like in this case along x axis and along y axis, then we call it a 2D plane. So this, your graph sheet is called an xy plane, that's why. And here this is the positive direction of x-axis, this is the negative direction of x-axis, this is the positive direction of y-axis, and this is the negative direction of y-axis. The point where all these lines are meeting is called the origin, 0, 0. So any point in coordinate geometry is in the form of an ordered pair. An ordered pair looks like x, y. So this is your x coordinate and this is your y coordinate. Further, this x coordinate is also called your abscissa, and your y coordinate is also called the ordinate. With this x value and this y value, we can locate any position, any point on this xy plane. So this x coordinate is actually the perpendicular distance from the y axis along the x axis, and this y coordinate or the ordinate is the perpendicular distance from the x axis along the y axis. So here if I give you a point 3, 2, this is the x coordinate, and you tell me what is the y coordinate? That is 2. So abscissa is 3 and ordinate is 2. Now this is the perpendicular distance from the y axis. So perpendicular distance from y axis along x axis is 3 over here. Okay, and then perpendicular distance along the y axis from the x axis, the y coordinate 2. So the point where this 3 and 2, these two lines are meeting, that point is what we are calling 3, 2. Now as you can see, we are having these two axes x and y. They divide my entire xy plane into 4 equal portions. These 4 equal portions are actually called quadrants. The word quadra as it is means 4. So here this is called the first quadrant, this is called the second quadrant, third and the fourth quadrant. Now in the first quadrant, as you can notice, here we have positive x and positive y values. Both x and y are positive. Then in the second quadrant, we have negative values for x but positive values for y. So here I can give you a point like minus 3, 2. So it will be minus 3, 2 like this. Okay. Then in the third coordinate, both x as well as y are going to have negative values like minus 3, minus 2. So this is the point. Then if we look at this example over here, for the fourth quadrant, here we see that x is positive but y is negative. So here I can give you a point like 3, minus 2, and that is homework for you. You plot it yourself. Then what is coordinate geometry? I just told you it's a link between algebra and geometry. So in algebra we discuss the equations, in geometry we discuss the figures. Using both of them we can call the thing as coordinate geometry. We've seen this before as well, where we were discussing linear equations and even in quadratic equations that we have equations, and for their graphical or geometric representation we were plotting them on the graph. So that's all about coordinate geometry. A very simple example to understand the importance of coordinate geometry is you visiting a movie theater. Okay, say you go and watch some 3D movie and you're given a ticket. Now usually your ticket would have an alphabet which means the row number. Okay, like G over here would mean that your row number is G, and the digits following it tell you the exact seat number. So that's how you're able to get a seat for yourself which is unique to you. Okay, nobody else can occupy this seat. So like that we can locate points on the xy plane if the x and y coordinates are known to us. Then here we have some of the applications of coordinate geometry. They are used in physics. So in physics we discussed how we throw a ball and then how it falls under gravity. So that entire trajectory can be shown by plotting a set of x and y values, and then we get a curve like this, which we discussed in quadratic equations as well. Then in engineering we use it in navigation, seismology, in art. Even if you're interested in game development, you want to make cartoons, and over there as well you require the exact coordinates. Then if you have a photocopy machine or a scanner, now we know that what is to be printed, but how does a machine know, and how does it fulfill our purpose so well? So it's because it is able to identify the positions of your dots, okay, the black spots and the white spots, the colored spots, and that's how it gives you an exact copy of your original document. Then a very good example is your own earth, your globe, your map, which are used to understand the earth. So here we draw some horizontal lines and some vertical lines. So we are basically calling them latitudes and longitudes. So the point of intersection of these lines help us in locating the exact position of some place. Okay, like for example, if you're in Delhi, then there'll be a specific latitude for that place and a specific longitude, which will help any person locate you exactly. So that's all about coordinate geometry. Now moving on to the distance formula. Now so far you've been calculating distances by making use of your ruler. You keep your ruler at the point from where you need to measure the distance, and you stop reading your ruler the point where you need to find out the length. Okay, now what if I tell you that I'm not giving you a ruler, but you have to tell me the exact length or the distance between any 2 points? Then how would you do that? Well, coordinate geometry will be your friend in that case, because if I give you say any 2 points P and Q, okay, let's say this point is having some coordinates x1 comma y1, and this is having the coordinates x2 comma y2. Then making use of this formula, also called the distance formula, you will be able to calculate this distance P Q. Okay, what is it? You first of all make a square root. Okay, then you take the difference of the two x coordinates. Okay, so you take it like x2 minus x1, and you make it whole square. Then you add over here the difference of the y coordinates, so it will be like y2 minus y1 whole square. Okay, now I'll like to bring this up to you, that we can also write this distance like x1 minus x2 whole square plus y1 minus y2 whole square. So basically if you're having 2 first in this square term, then you should have the second term only okay, in the second square bracket as well. Okay, and if I give you like x1 here, then it should be y1 here. It cannot be like you write x1 minus x2 whole square and then you write plus y2 minus y1 whole square. That will be wrong. So x1 corresponds to y1, x2 corresponds to y2. Okay, and we can even represent these points on a graph sheet. You know how? So P is x1 comma y1. So this distance, perpendicular distance from y-axis would be x1, and then from the x-axis, if you take this distance, will be y1. Here this is x1. Then here for point Q also you can say that this distance is going to be what? x2, and this distance is going to be y2, and the distance between these 2 points can be given by this particular formula. Then we'll see how we derive this distance formula. So I hope it's clear to you that this distance, the perpendicular distance from the x-axis, is your y coordinate. So this distance will be y1 and this distance will be your x1. Similarly, for point Q, you tell me what is this distance. This is perpendicular distance from the y-axis, which means this is the x coordinate x2. This is perpendicular distance from the x-axis, which means this is the y coordinate y2. Then you have to draw perpendiculars from points P and Q on the x-axis. Okay, so let's say this point over here is R, and from Q, if you are dropping a perpendicular, let's say this point over here is S. Then from P you drop a perpendicular on QS, and let's say you drop it at point T. Alright, so this OR distance will be what? We just see, we've just seen this, it's OR equal to x1. Okay, perpendicular distance from the y-axis. Then quickly tell me what will be OS. OS, this entire distance, it is x2. So if I ask you to find out RS, what is this RS? RS will be OS minus OR. Your OS was x2 minus x1 is going to give you OR over here. Now this RS is same as your PT, because you're having sides of a rectangle. Okay, here your PRST is actually forming a rectangle, and we know that opposite sides of a rectangle, they are equal in length. Okay, this was for the X coordinates. Then for the Y coordinates, you tell me what is SQ, what is ST, and what is QT. Okay, so SQ is the perpendicular distance from x-axis, and this distance is y2. ST over here is what? This is this distance PR only, so it's going to be y1. And what about QT? It's actually SQ minus ST, so it's going to be y2 minus y1. With all these measurements in hand, we are going to consider triangle PQT. So in triangle PQT, which angle is 90 degree? This angle T, okay, or we can call this angle PTQ. This is 90 degrees. Then if it's 90 degree, you can apply Pythagoras theorem over here. So this means that what is the hypotenuse? PQ. So PQ square is equal to perpendicular square, which is QT square, plus the base square, which is PT square. Okay, you can give the reason over here using Pythagoras theorem. Then do we know QT and PT? Yes, this is QT and this is your PT. You just need to substitute. So PQ square is equal to QT square, which is y2 minus y1 whole square, plus PT square, which is x2 minus x1 whole square. Now if you take square root on both sides, you will get PQ is equal to under root of, I'm just interchanging their positions, okay, x2 minus x1 whole square plus y2 minus y1 whole square, which is exactly what we discussed as the distance formula. So you need to learn this, it will come in very useful. Okay, just remember that it could have been x1 minus x2 whole square as well, but then the next term should have been y1 minus y2 whole square. So 1 corresponds to 1, 2 corresponds to 2. Then whenever we take square root, we get two roots. Okay, we get a positive root and we get a negative root. But since distance can never be negative, therefore we only consider the positive root. Okay, so here you never have a minus, you'll always get a plus. Okay, now here this is a special case of distance formula, which is distance from origin. Trust me, it's much simpler than the distance formula itself. So here like so far we've been taking 2 points, right? So one point was x1 comma y1, the other point was x2 comma y2. Now I'm saying that one point is in the form of x1 comma y1, the other point is now origin. So here if this point is x1 comma y1, the other point from which I'm measuring the distance is origin, which has coordinates 0 comma 0. Okay, so considering this only as x2 comma y2, if I make use of the distance formula that we had earlier, let me call this PQ. So PQ was what? Under root of x2 minus x1 whole square plus, you tell me the second term, y2 minus y1 whole square. Good. Then what is x2 over here? I'm saying let's take this as 0 comma 0, x2 comma y2. So it becomes 0 minus x1 whole square plus 0 minus y1 whole square. Now it will give me minus x1 whole square plus minus y1 whole square. We know that square of a negative term is positive only, so we get x1 square plus y1 square. That is PQ. So this is distance from origin. So if I give you a point P x comma y, that means perpendicular distance from the x-axis is going to be y, and perpendicular distance from the y-axis is going to be x units. Now since I have dropped a perpendicular from P on the x-axis, that means this angle is 90 degree. So over here, let me call this, say, point Q. If I apply the Pythagoras theorem, the hypotenuse being OP, so I'll get OP square is equal to PQ square plus OQ square. I can find out this OP distance, okay, which is exactly what we need to find out, the distance between origin 0 comma 0 and the given point P x comma y. So in that case, PQ is y, so y square, OQ square is x square, and now if you take square root on both sides, you get under root x square plus y square. So you get the same thing, even if you directly substitute 0 comma 0 in the distance formula, or you do it graphically like we calculated the distance formula, both give the same result, but what is of importance is this result, okay? The distance from origin will just have under root x square plus y square term. Now it will become clearer with examples. So you've been given 3 points and they're asking you if they form a triangle. So what you need to do first is, let's say this point is A, this point is B, and this point is C. Now calculate, now you know that if I'm going to have a triangle will have three sides. So calculate the distances AB, BC and AC. Okay, in all of them you need to make use of the distance formula. So AB, take this coordinate. Let's say first we take this. Let's say this is x2, y2. This is x1, y1. Okay, so this will become x2 minus x1 whole square, which means minus 2 minus 3 whole square, plus y2 minus y1 whole square, which is minus 3 minus 2 whole square. So if you solve this, minus 5 whole square, which is 25, and this is also minus 5 whole square, which is 25. So this becomes square root of 50. Okay, in a similar way you have to calculate BC. So this is in units. Okay, since we don't know centimeter, meter, so we'll just have this distance as units. Okay, distance cannot be unitless. So BC is also calculated in a similar manner. So you do 2 minus 2 whole square. So that becomes 2 plus 2 whole square, plus 3 minus 3 whole square, which is 3 plus 3 whole square. I'm doing nothing but making use of distance formula. You can write it somewhere for your own reference, that it is under root x2 minus x1 whole square plus y2 minus y1 whole square. Okay. Here also you can say using distance formula. Okay. So what is 2 plus 2? It's 4. 4 square is 16. 3 plus 3 is what? 6. 6 square is 36. So 16 plus 36 gives me root 52 units. Then calculate AC. So it will be 2 minus under root of 2 minus 3 whole square plus, you tell me the second term, 3 minus 2 whole square. What is 2 minus 3? That is minus 1. So minus 1 whole square is 1. Exactly. Then 3 minus 2 is again 1. 1 square is 1. So this is root 2 units. Okay, now we can see that sum of any two sides is greater than third side. Tell me if you notice this. So if I take AB and BC, okay, if I take AB and AC, okay, this distance is actually equal to the length of third side, but it's like greater than equal to relation is there. Okay, so in such a case, when you have sum of any two sides as greater than equal to third side, we say that the 3 points are actually forming a triangle. So implies that A, B and C form a triangle. So the answer to this question is yes. If so, name the type of triangle formed. Now we have different types of triangles. We have isosceles, equilateral, scalene, right angle. Let's see which one is it. If you look at the distances alone, you'll get to know that your BC square is actually equal to AB square plus AC square. Tell me if you notice this. What is BC square? That is root 52 square, which is 52. AB square is root 50 square, which is 50. AC square is root 2 square, which is 2. 52 is equal to 50 plus 2, which is true. So this is a right angle triangle. How are we saying this? We are making use of the converse of Pythagoras theorem. Okay, from converse of Pythagoras theorem, we can say that if the sum of squares of any two sides is coming equal to the square of the third side, then it means that one angle has to be 90 degree, and in this particular case also we'll have one angle as 90 degree, which could be maybe angle A, I guess. So you can make it out actually. So let's say this is a perpendicular, root 50 units. Your hypotenuse is root 52 and this is root 2. So this distance is AC and then this is BC. Okay, so that means angle A is equal to 90 degree from here. So this is a right angle triangle. Then show that the points are the vertices of a square. Now if you want to show that these four are the vertices of a square, let's call them A, B, C, D. So first label the points. Then to prove ABCD a square, you need to make sure of two things. Number one, all sides are equal. Number two, a square would have two diagonals, so the two diagonals should be equal. Okay, if you are able to prove both of them, we can conclude that yes, ABCD is a square. So to find out the sides, you need to actually find out AB, BC and your AC. No, sorry. We'll first find out CD. And then we need to find out DM. So this is for the sides, okay? So if I give you a square like A, B, C, D, first let's find out the sides. So making use of distance formula, AB will be 4 minus 1 whole square plus 2 minus 7 whole square. You have to take the corresponding x and y coordinates only, okay? Don't make a mistake there. So 3 square is 9, 5 square is 25. So here you get root 34. Then similarly find BC, CD and AD and tell me the answer. This should be minus 1 minus 4 whole square plus minus 1 minus 2 whole square, which will again be root 34. Tell me what you're getting for the other two sides. Okay, I'm on the last side. So we have minus 4 minus 1 whole square plus 4 minus 7 whole square. Now all these distances are coming equal to root 34 units. So the first condition has been proven. All sides are equal. Then let's find out the diagonals. What are the diagonals here? AC and BD. So find out these lengths also, AC and BD. Okay, you can give the reason over here somewhere using distance formula. The same reason you can give for the diagonals as well. So AC will be minus 1 whole square plus minus 1 minus 7 whole square. So this will be minus 2 whole square, that is going to give me 4, minus 8 whole square, which is 64. So this is root 68 units. Similarly, find out BD. That will be minus 4 whole square plus 4 minus 2 whole square. Tell me, are you getting BD as root 68 units? If your answer is yes, then you are on the right track, because the diagonals are also turning out to be equal and equal to root 68 units. So the two conditions are fulfilled, hence ABCD is a square. But how do you write this? You say that since AB is equal to BC is equal to CD is equal to DA and AC is equal to BD, which means sides are equal, diagonals are equal, implies that ABCD is a square and hence proved. Then we have example 3 over here. So there are 3 girls who are sitting in a classroom, Ashima, Bharti and Kamala, and their positions are A, B and C respectively. So this is A 3,1, B 6,4, C 8,6. Okay, so you have to tell if they are seated in a line, which means if I can join them by a line. Okay, so how do you tell this? So in other words, this question is asking you to tell if A, B and C are collinear. Now collinear means if 3 points are lying on the same line. So that's exactly what you have to tell here, right? That if they're seated in a line. So if you have to prove that 3 points are collinear, you need to prove that sum of any two sides is equal to the third side. So for that you need the values of the sides, right? So find out AB, BC and AC. Make use of distance formula in them and let's see what are we getting. So AB, so 6 minus 3 whole square, square root obviously, plus 4 minus 1 whole square. So that is 3 square 9 plus 3 square 9 again. So this is root 18. Okay, then if you find out BC, that is 8 minus 6 whole square plus 6 minus 4 whole square. So that is root 8 units obviously. And talking about AC, here it's going to be 8 minus 3 whole square plus 6 minus 4 whole square. So this is going to be root 50. Now further I can take 9 common over here. Okay, so I am getting AB as root 18. So I can write this as under root of 9 into 2. I can pull out this 9, then it will become 3. So it will become 3 root 2 units. If I take BC, that is root 8, that is root 4 into 2. I can plug this 2 out, okay, because this 4 will become 2 outside. So it will become 2 root 2 units. And if you find out AC, which is root 50, that is root 25 into 2, I can take out this 25, it becomes 5. So 5 root 2 units. So we see that AB plus BC is equal to AC, isn't it? See, 3 root 2 plus 2 root 2 is equal to 5 root 2, as you can see from here. So we've proven that sum of any two sides is equal to the third side. Hence A, B and C are collinear. What does that mean? That they are all lying on the same line, which means that these 3 girls are also seated in a line. So the answer is yes, and the reason is all the calculations that we've shown. In example 4, you've been given a point x comma y. So let's say that this point is P, x comma y. It is equidistant from points 7 comma 1 and 3 comma 5. Let me call this point A and let me call this point B. Equidistant means it is at the same distance from the 2 points. Okay, so this means that AP is equal to BP because P is equidistant from A and B. Even the name will tell you equidistant, equal distance. Okay, so if I do squaring both sides, I'll get AP square is equal to BP square. Squaring both sides. Okay, then you use distance formula. Okay, now the square root term won't be there because I've taken squares, so you'll just have x2 minus x1 whole square sort of terms. So AP, which means it's going to be x minus 7 whole square plus y minus 1 whole square is equal to BP square, which will be x minus 3 whole square plus y minus 5 whole square. Then you need to open the brackets. Okay, make use of the formula a minus b whole square. What is that? A square plus b square minus 2ab. So this will become x square plus 49 minus 14x plus y square plus 1 minus 2y is equal to x square plus 9 minus 6x plus y square plus 25 minus 10. I have done nothing but made use of this formula. Now see what all terms you can cancel. We can cancel x square from here, x square from here. Then we can cancel y square from here, y square from here. Collect the x terms. So I'm having minus 14x over here. Let me shift this minus 6x on the LHS. So it will become minus 6x will become plus 6x minus 14x. Okay. Then what about the constant terms? Here we are having 49 plus 1. So that is 50. Let me shift this minus 2y also on the RHS. So it will become 2y. So 2y minus 10y will become minus 8y over here. And add the constants over here, 9 and 25, which is nothing but 34. So this is minus 8x. Okay, and let me write this like plus 50 equal to minus 8y plus 34. Let me do one thing. Let me shift this 50 over there. So I'll get minus 8x. Let me shift this 8y over here. This will become plus 8y. Here we'll have 34 minus 50. And that is nothing but minus 16. If you multiply this entire equation by minus 1, I'll get 8x minus 8y is equal to 2 and 16, sorry. And here I can take 8 common. This is x minus y is equal to 16. So 8 2's are, and I get x minus y equal to 2. So I just made use of the concept of equidistance to say AP and BP are equal. I did squaring on both sides, made use of distance formula, and then there is this simple algebraic simplification which made me get the relation between the between these variables x and y. Then we have example 5. I believe this is the last example on distance formula. So you have to find a point on the y-axis. You know that a point on the y-axis will have x coordinate 0. So it is of the form 0 comma y. So let's say that this point is P0 comma y and it is equidistant from points A and B. Now who will tell me what is equidistant? Equidistant comes from equal distances. That means AP and PB are going to be equal. Alright. So then you do squaring on both sides. You will get AP square is equal to PB square. Okay. So here we've done squaring. And here you can say that P is equidistant from A and B. And make use of distance formula. So AP square will become what? It will become 6 minus 0 whole square plus 5 minus y whole square. And PB square will be minus 4 minus 0 whole square plus 3 minus y whole square. So here what is the reason? Distance formula is being employed. Now 6 square is what? 36. Again make use of the formula a minus b whole square. That will give you 25. Plus y square minus 10y is equal to 16 plus 9 plus y square minus 6y. Do write here the formula a minus b whole square is equal to a square plus b square minus 2ab. Okay, then y square gets cancelled. Bring this 6y over here. So we'll get 6y minus 10y. Take all the constant terms on the RHS. So 16 plus 9 was anyways 25. You bring this 25 and 36 over there. So 25 cancels. 6y minus 10y is minus 4y. And this is minus 36. Minus cancels. 4, 9. And this gives me y equal to 9. But is this it? No, we were asking about the point and not about the coordinate of that point. So the point P was 0 comma y, which is 0 comma 9. So this is your required point. Now how can you verify your answer? It's very useful if you can verify your answer, because that will make you correct your solution in case you go wrong. So if you know this point P, you can find this distance AP, you can find this distance BP. So again, make use of distance formula, and I guess you should be getting root 52 on solving. You can verify this, and if P is coming out, AP and BP are coming out to be equal, it means that P is equidistant from the points, and hence indirectly, in going in a backward direction, you are able to verify your answer. Then we have a very important topic after the distance formula, which is the section formula. So where do we use this? So if I give you a point A, a point B, okay, now very conveniently, making use of distance formula, if I give you the coordinates of A and B, say x1 comma y1 and x2 comma y2, very easily you will be able to find out the distance between the 2 points. But what if I tell you that there is another line which is intersecting AB, and that intersection is happening at point P, and this point P will obviously divide this line segment AB into two halves, right? AP and PB. Now we don't know in which ratio it's going to happen, so let's say that the ratio in which this division is happening is M1 is to M2, which means this is M1 and this is M2. And I want to know the coordinates of this point, say x comma y. So for that, this section formula comes in very handy. Okay, now this is the section formula, but how do you remember it, right? Right now it seems like very difficult, like a tough task. How would you do this? But it's not at all difficult. You need a point, right? So a point will have an x coordinate, it will have some y coordinate. So here basically we want x comma y, an ordered pair. So here the denominator will be m1 plus m2. Remember what was m1 and m2? M1 is to M2 was the ratio in which this internal division was taking place. So we call such a division internal. In higher classes, you'll see what is an external division, but this chapter is limited to internal division. So let's say P is internally dividing the line segment AB in the ratio M1 is to M2. So that M1, M2 is this. Okay, you just sum it up, and that becomes a denominator for both the coordinates x as well as y. Talking about the numerators, how do we do this? So take M1 term, write M2. Okay, write M1, write M2. Put this plus sign in between. If it's 1, write x2 over here. I'll have the x terms over here. Why? Because this is the x coordinate and this is the y coordinate. So here you should have the y terms. So if it's 1, have 2. If it's 2, write 1. If it's 1, 2, 2 and 1. So basically M1 is there. So you multiply it with x2. Okay, if I give you M2, you multiply this with x1. That was for the x coordinate. Now for the y coordinate, you need to have only the y terms. So M1 will be multiplied by y2 and M2 will be multiplied by y1. So 1 is multiplied by 2, 2 is multiplied by 1. Okay, now let's quickly see again how we are memorizing this formula. So it's going to be of the form x comma y. Alright, if internal division is taking place. So the point where this division is taking place will be of the form x comma y. So it will have some x terms, it will have some y terms. So I make a comma in between. Now there is some numerator, there is some denominator. The denominator is very simple. If the ratio is m1 is to m2, then what is the denominator? m1 plus m2 for both of them. Then I'm telling you that you just write over here m1. Okay, leave some space, write plus, write m2 and leave some space. Write m1, leave some space, write plus, write m2, leave some space. Okay, now with m1, you will have the second term, with 2 you will have the first term. So since we are talking about the x coordinate, so here we'll just have the x terms. So if it's 1, this will be 2. If this is 2, this will be 1. Now here we are talking about only the y term. So you will have y and y. If it's 1, this will be 2. If this is 2, this will be 1. So that will help you remember. Anyways, we'll be talking about its derivation, its proof. So here you have O as 0, 0, it is the origin. Internal division is taking place, M1 is to M2 is the ratio, P is the point which is dividing this line segment AB. AB is having the coordinates x1, y1, B is having x2, y2, P is x, y. Now, what I want you to do is you need to drop some perpendiculars. Okay, so from A, you drop a perpendicular AR on the x-axis. Then from this point P, you drop a perpendicular. Let me call the foot of this perpendicular S. From B, let me call this foot of perpendicular as T. So this is R, S and T. Alright. Then you need to draw some perpendiculars from these points and some parallel lines. Okay. So from this point A, you will draw AQ. Okay. Make this AQ. This will also be perpendicular. Obviously, it's parallel to the x-axis. Then from P, you make over here a perpendicular C. This is perpendicular to your BT. Okay, this line, and they're parallel to y-axis. Okay, so once you've done this construction, then you need to find out some things in triangle PAQ. Okay, PAQ is which triangle? PAQ. Let me call this Q actually, and yeah, let me call this point as Q. Just make that correction. So you're considering this triangle PAQ, and we're considering the triangle BPC. Now here you know that this angle Q and C, they are equal to 90 degree, because here PC and your AQ, if you can see, they are perpendiculars. Okay, perpendiculars to PS and BT respectively. Okay, then further we can see that these are parallel lines. Okay, this PS is parallel to your BT, and it's even parallel to AR. Okay, they're all parallel and also parallel to the y-axis, so we can make use of properties of parallel lines, and then we can say that this angle PAQ is equal to angle BPC. Okay, angle PAQ is equal to angle BPC. We can say that they are corresponding angles, so they are equal. This is a property of parallel lines. If I've proven two corresponding angles of two triangles equal, if you remember similarity, then we can say triangle PAQ is similar to triangle BPC, and the similarity criterion that we used is AA, which is also called AAA. So if two triangles are similar, their corresponding sides are in the same ratio. So we can say PA upon BP is equal to AQ upon PC is equal to PQ upon BC. You can make this equation number 1. Now we'll calculate some distances. Let me write them over here. So calculate AQ. Okay, AQ. If you can see, you will know that this is same as RS, because ARSQ is a rectangle. So AQ is same as RS, and RS is OS minus OR. Now you know what is this OS? This entire distance is X, and this OR distance is actually X1, because this is the X coordinate. So this distance is X1. Okay, and this is the X coordinate. So this is X. So this is going to be X minus X1. Okay, then you calculate PC. PC is same as your ST, because this PCTS is actually a rectangle. Opposite sides are equal. So I'm basically writing these sides in terms of sides which we are having on the x-axis, because it's easier to find them then. Okay, so now your ST is what? It is OT minus your OS. Your OT is X2 and OS is X. Then you find out PQ. PQ is going to be what? This entire thing PS minus QS. And further, this QS is same as AR, because this is also a rectangle AQSR. So PS minus AR. Now we know what is PS and what is AR. So this is going to be Y minus Y1. Okay, this distance over here is Y1, and this entire thing PS is Y. We're just making use of the fact how we are writing X and Y coordinates graphically. Okay, then tell me what is BC. Okay, BC over here, this is going to be BT minus CT. And this CT is same as PS, because PCTS is a rectangle, so opposite sides are equal. So BT minus PS, if you do, this is Y2 minus Y. Now we'll substitute these values in equation number 1. Okay, so one more thing over here. Here we are saying PA upon BP. Now if you notice carefully, PA upon BP should be equal to M1 upon M2 based on the basic construction. Since P is dividing line segment AB in the ratio of M1 is to M2, therefore this distance PA over BP should be M1 upon M2. So I can say M1 upon M2 over here, and instead of aq upon pc, I can substitute x minus x1 upon x2 minus x. Okay, and instead of pq upon bc, I can substitute y minus y1 upon y2 minus y. Okay, I will individually solve these equations and this set of equations. Let me clear up some space. Okay, so if you equate m1 upon m2 equal to x minus x1 upon x2 minus x, you need to cross multiply first of all. So it will become m1x2 minus m1x is equal to m2x minus m2x1. Collect the x terms. Okay, so this will become m2x minus m2x minus m1x is equal to minus m1x2. I'm just shifting this over here, minus m2x1. If you multiply this entire equation by minus 1, you will get m1x plus m2x is equal to m1x2 plus m2x1. Now here you can take x common, so it will become m1 plus m2 is equal to m1x2 plus m2x1. I'm just simply solving it, okay, simplifying this. So I make x as the subject of the formula, so this goes in the denominator on the RHS, so it becomes m1x2 plus m2x1 upon m1 plus m2. If you remember in the section formula, I just told you that the x coordinate is numerator upon denominator. Denominator is m1 plus m2, and then we have m1 m2. You leave some space and you have a plus sign in between, then you write x. If it's 1, you write 2. If it's 2, you write 1 over here. So this is your x coordinate. We've solved for this x coordinate. Now we'll solve for the y coordinate in a similar manner by considering these two ratios, m1 m2 and y minus y1 upon y2 minus y. Okay, there was a quality relation in them, and now what is the first step? Just like we did it for x coordinate, we'll go in the similar manner. Actually, it's the exactly same way. So if you cross multiply, you have m1 y2 minus m1 y is equal to m2 y minus m2 y1. Now just shift the y term. So let me bring this m1 y term over here, and let me take this term over here. So I'm basically saying m1 y2 plus m2 y1 is equal to m2 y plus m1 y. If you take y common, again you will get y as m1 y2 plus m2 y1 upon y1 plus y2. So again we've got the y coordinate, and as you can see, this is m1 plus m2. Okay, in the denominator, numerator has m1 term, m2 term, in between there is plus. You write the y terms because this is the y coordinate. With 1 comes 2, with 2 comes 1. So these are your x and y coordinates for the point P.